Hello and welcome to Future Construct. I'm Mark Oden, the owner of BIM Designs Incorporated, and we're also here at Geo Week in 2023 in Denver, Colorado. And I'm here with Kara Fragola, an engineer at Skanska. Thank you for coming onto the show today, Kara.
Thank you, Mark. Excited to be here.
Thank you so much. I'd love to hear a little bit about your background and also what brought you to Skanska.
Yeah, absolutely. So my name is Kara. I'm a field engineer at Skanska. I started out as an intern at Skanska actually in 2018. I graduated from Columbia University with an engineering degree, a bachelor's and then a master's degree. And I really just always was very interested in the built environment. Growing up in New York, close to the city, I was around a lot of high-profile construction projects. Always just piqued my interest, so I went down the engineering route. I tried out a little bit of design, a little bit of construction, and construction was where my heart was. So.
That's wonderful. Well, yeah, welcome to Skanska. I'd love to hear about your career at Skanska and where you came in and where you are today. Absolutely.
So I started out as an intern in our equipment department, and that gave me a really great insight into the back end of construction. It's all glamour when you're on the job site, but nobody thinks about what equipment we need, where it is when it's not on the job site, things down to where we're storing the refrigerators that are going to end up in a job site trailer. We had everything from our young tans, all of our equipment stored on this site. So this allowed me to really learn about the different pieces of equipment, and that really helped me when I was in the field to actually know what things were called, because when you first get out there, you don't really learn a lot of these things in the textbooks. From there, the next summer, I worked at LaGuardia Airport. So this was a really, really exciting project for me to be a part of as a New Yorker. LaGuardia Airport was famously rated one of the worst airports in the country. So I was glad to have my part at flipping the script on that. And I spent a year there. I worked throughout the school year as well. Commuting from Columbia was, not a bad commute, so spent a lot of time there. Then I started out as a field engineer. We actually have a program called CCTP. So it's our core competency training program. Every year, a number of new hires come into this program. It's a 2-year rotational program, and it gets you really involved in every different aspect of what we do. So you go from project to project, and you hold different roles such as assistant superintendent, field engineering, estimating, safety, and even a wild card, which is a little bit different for everybody, but I had experience working in the corporate office.
Nice.
So I came out of that program, worked on a number of different really exciting projects, and I'm currently working at our Croton-Harmon train station project, which is a Metro North project. It's basically building a whole back office for them, a whole track site, and it's how everybody from Westchester will commute into New York City.
That's amazing. That's incredible. And what's your role in that particular project?
So in that project, I manage our architectural scope of the job. So it's everything from the tile in the bathrooms to the CMU walls. So we're at the tail end of the project, so my scope is really ramping up with all the finish work. But it's a really exciting project because it has a lot of mix of heavy civil type work, but also these really detailed finishes that I hadn't had much experience working with before. So.
Wonderful. And then tell us a little bit about Skanska itself, the organization at scale, and what do you feel is of key importance for Skanska this year?
Yeah, so Skanska is a global construction company. We have over 30,000 employees across the globe. It's a Swedish-based company, but we do a lot of work in the United States. We have 3 divisions. We have our heavy civil division, which I'm a part of, our building construction division, and also our commercial development division. And in the U.S., we have over 7,000 employees, and we do a lot of large-scale government projects in my division. And Skanska itself, we're known to be a leader and an innovator in project execution and also in safety.
Very cool. And then I know that you may not be working on it at this moment, but you and I were talking earlier that you've been a part of or lead the drone program with Skanska. Can you share your interest in drones and what brought you into that direction?
Definitely. So when I was in high school, I led the social media platforms for my high school. And every year I wanted to make, a kind of like a promo video. So it was a private school, so it helps out to get those promos. And I was a senior at the time, and I wanted the senior video to be spectacular. So I was like, what if I could get a drone for this video? I ended up making it happen, got a drone, learned how to fly it, made a cool video, people liked it, and I realized that this was something that was really exciting to capture a visualization from a bird's eye view and just get really interesting angles and shots. So I started flying drones recreationally, making videos for friends and family. And then when I came to Skanska, I saw that some of our other divisions had drone programs, but the civil division didn't. So I leveraged some of the knowledge of my colleagues in other divisions, and we started the drone program for civil. We piloted it on one of our biggest projects. It's a $1.5 billion project in New Jersey. It's called the Portal North Bridge Project. It's owned by Amtrak and New Jersey Transit. And it had some challenges. We were nestled between two very highly restricted airspaces, Newark Airport, Teterboro Airport, flying over water, flying over marshland. We needed like 6 launch locations, 50-page safety plan, but we made it happen, and it's been incredibly successful, and we're expanding it, many more projects, more pilots, more equipment, and seeing where this could take us.
That's very impressive. How large would you say is that program now to date?
So we're really still in the early stages, so just got a couple pilots in training, myself, and just growing our equipment, looking at new projects we can help out and get into. So it's definitely in the early phases. It's been about a year since we started, but we have a lot of exciting plans coming up.
Very cool. What's the FAA certification process like?
Yeah, so for our region, we have a lot of really restricted airspaces, just in New York alone. I mean, there's several airports. So to get the licensing alone, you have to pass what's called the Part 107, which is the FAA's licensing. So it's a sit-down test, a written test. It's about an hour and a half. And then after that, you're certified to fly, but you might not have ever flown before. There's no in-person actual flight test. So what we do at Skanska is after we go through the training and the certification and actually having your license, we go through a Skanska training. So we'll go through our best practices, and then we'll actually get our pilots some experience with actually flying a drone, because that's the main part of it. So, and then when you want to fly in restricted airspaces, we have our protocols and our ways to submit waivers to the FAA for authorization, and that's how we've been able to fly close to our airports.
Very cool. You had mentioned earlier that Skanska had other drone programs, and you worked with your colleagues to exchange information. What are some best practices that Skanska has when it comes to sharing information amongst colleagues?
Yeah, so Skanska has a lot of knowledge sharing platforms built in. So like I said, we're a global organization. There are experts, right within the company all across the globe on all different types of emerging technologies. So for us, we've created a knowledge sharing network that we house right in our Teams platform, which is everyone has it, easy to use, and we have different channels for different technologies. Everyone who's interested joins in on the conversation, and that's where people can ask questions, they can learn who are the experts in different technologies, make connections, and we also have monthly meetings where people present on different topics that they're knowledgeable about, and it really just opens up the possibility for us to connect as an organization and also for us to leverage the experience of others. So that's how I was able to understand who's the experts in this in other regions and how can we connect.
Wonderful. And so you're here at GeoWeek 2023 and you'll be presenting, is that right?
Yes.
Absolutely. Wonderful. Would you be able to share the name of the presentation and also what your presentation is about?
Yep. So my presentation is taking construction from eye level to sky level, driving innovation at Skanska through drone technology, and it's part of the Future of AEC Workflows section.
Oh, wonderful. And as part of your presentation, as part of the section, what do you feel are the key topics or key takeaways? So
what I'll be talking about is I'll actually be speaking a lot about the Portal North Bridge project and how Skanska is leveraging drone technology for these specific, large-scale infrastructure projects. So I'll be going into the details of what our workflows look like, what data we're looking to extract, how we're sharing it with our stakeholders and with our teams, and overall how it's benefiting us as an organization. And then I'll touch on some best practices for starting a drone program, and then I'll finish with looking at the future of how drones will serve us in the construction industry.
So cool. I'm so excited to see this. In terms of best practices for starting a drone program, what are 1 or 2 tidbits that you could share with the
Absolutely.
audience?
The number one thing is, of course, the business case. So what is your organization looking to get out of it? And most importantly, what are your clients looking to get out of it? of it. So a lot of clients may have certain restrictions. That's so important that you understand before you start your program. So one quick example, we're working on a project, the Benjamin Franklin Bridge, and on that project we actually have to use drones made in America. So if you went out and you purchased a DJI drone, it may be great, but may not be able to use it for what your client's looking for. So just understanding all of that.
Mm-hmm. Yeah, thank you so much for sharing that. In addition to presenting, what are you excited about seeing at GeoWeek 2023, and what are some technologies that are important to you and also to Skanska?
Yeah, I'm just super excited to meet a lot of the industry experts, learn about the new emerging tech, looking forward to learning more about reality capture, digital twins, and some best practices for BIM workflows.
Cool. That sounds right up our alley as well.
Yep.
Well, thank you so much, Kara. I really appreciate your time, and I look forward to seeing you out there.
Thanks so much.
Yes, ma'am. Hello and welcome to Future Construct. We're also here at GeoWeek 2023 in Denver, Colorado. I'm Mark Oden, the owner of BIM Designs Incorporated, and I'm here with Jason Stoker, a physical scientist with USGS. Welcome, Jason, and thank you so much for joining us today.
Hey, thanks for having me.
I'd love to hear about your background a little bit and what brought you into the USGS.
Okay, yeah. My career path starts probably back in the late 90s. I was a grad student up at Colorado State, and I was out in the field for the Forest Service, measuring trees, looking for fire history to see how the climate has changed over time and how ponderosa pine forests, which are in the Colorado Front Range, historically responded to those. We were out mapping trees. And one of the things about ponderosa pine is when they get over 400 years old, they start flattening out on the top. So they have this really unique structure that they do once they start getting really old. And my advisor at the time, he said, hey, I have this colleague. He's working on one of the first commercial airborne LiDAR sensors, and he was wondering how well it did in vegetation. And so since we had gone out and mapped all these trees, we knew their locations, we knew what their shapes were like. They flew over the site in the late 90s and maybe around 2000, and we were able to successfully show that you could see the structural characteristics of these old growth trees.
Wow.
And so that's really what got me going on the LiDAR bug, and I graduated around 2002 with my master's, and right after that the USGS had a job announcement for a LiDAR specialist to come in and start bringing in LiDAR-derived DMs into what they called back then the National Elevation Data Set. Historically, USGS had done all the topo maps and contour lines. They converted that to a digital form, which was the National Elevation Data Set, and then started incorporating LiDARs as it came in. And so we started doing that around 2002, plugging in bits and pieces as we would get data. And one of the things I noticed at the time was a lot of people only cared about the digital elevation models. They weren't cared about the source point cloud data. So we started something called CLIC, which is the USGS Center for LiDAR Information, Coordination, and Knowledge. And so what we were really trying to do is dig all these point cloud data sets that people were collecting but then throwing away because they only cared about the rasters. And we were trying to collate those together and put it into a national database. And so we started getting that going around 2006, 2007. And then, we started thinking, hey, wouldn't it be great to have this kind of data for the entire country? So in 2007, 2008, we had these grassroots workshops to kind of organize and see how we may be able to do what we called back then the National LiDAR Data Set. That turned into an action forward to get a study called the National Enhanced Elevation Assessment Study. So we went out and surveyed tons of state, federal, local, private sector people to try to get the value and the costs of collecting a national LiDAR data set. And so we did that for a couple years, got that study. It showed a really nice return on investment with the taxpayer dollars, because we're using your money to collect this data all across the country. And it was about a 5-to-1 return on investment. And with that, we started what's the program forward we started. It's called the 3D Elevation Program. And so around 2014, 2015, that program started getting put in place, and we started operationally collecting LiDAR to a defined specification. So anybody that wanted to collect LiDAR, airborne LiDAR, anywhere across the country, and if they wanted funding help to partner in, if they collected the data to the specification, then we could all start combining these puzzle pieces together, because we couldn't afford to collect the whole United States at one time. And so we've been actively doing that with 3DEP since then. We are about 90% of the US is either available or in progress with LiDAR data. It's probably a different kind of LiDAR than you all are used to. Our point densities are at least 2 points per square meter. And it's the RMSEs compared to survey checkpoints in flat open areas is around 10 centimeters. So we go around and we have the private sector guys that collect the data for us, compare that to survey checkpoints and make sure that the data is as accurate as we need. And so that's what we've been doing. 3DEP's been a really great success story. We make the data available to the public for free. Cloud companies, well, Amazon, Microsoft, Google, they've all gotten copies of this data and are making it available. So we're getting a wide intake of people accessing and using this data now. And so what I'm here for this show is we have a presentation on Wednesday talking about the next generation. So now we're at 90% of the US available or in progress. So we're starting to think, how do we design the next generation of 3DEP to accommodate new sensor modalities? Inland topobathy is a big thing for us now. So now we can, there's instruments out there that can get us elevation information above and below the water surface. So we want to start creating a continuous three-dimensional model above and below the water surface inland. Merge that with our colleagues at NOAA who have been doing that on the coast for years and years. And then trying to set up some new ways to get access to the data that's a lot easier than the typical old school download and do stuff with the data. So that's in a nutshell from start to finish.
Yeah, I love that, Jason. Yeah, thank you so much. I mean, what an incredible career. And in a span of time, how much time was that between when you graduated and where we are today?
Almost about 20 years now.
20 years, wow, yeah. Congratulations. And you've been able to be a part of and initiate many of those programs that you just mentioned.
Yeah.
That's incredible. While you were explaining that, I was wondering, it sounds, from what I heard from you, the USGS collects and also partners with other firms to collect data, aggregates that data and finds a way to share that data all across the country to individuals or firms that want it. I was wondering if you could share with me some use cases or some examples of where that data has been consumed and used, and the ROI that you're seeing or saying is returning back to the community.
Yes, the nice thing and the bad thing about airborne LiDAR is it covers such a wide range of uses. People use it for all kinds of things, so it's kind of hard to sell it as solving this problem. It solves so many, or helps solve so many problems, that it's hard to get your arms around it. But two of our biggest federal partners that we work with are FEMA. Mm-hmm. FEMA uses the LiDAR that's being collected for 3DEP to update and improve their flood rate maps. And then NRCS, they use the data to do precision agriculture studies mm-hmm. and understand, how soil erosion and fertilizer applications and things like that are being used. Mm-hmm. So those are kind of, but there's the 3DEP has a working group that covers tons of federal agencies who are interested in LiDAR, and the idea is we collect one LiDAR data set, and then all these different agencies can use it for all their different applications. We also partner especially with state and local folks. Mm-hmm. So the state agencies, they have all kinds of their needs that they need the data for, whether it's for urban planning or their own flood applications, or doing things like smart city development, stuff like that. So because airborne LiDAR is so expensive to collect, we can all put our money together into this pot, collect one data set that everyone can use. They know what they're getting because we've developed this specification. And USGS takes a lot of time QAing the data to make sure that what we've contracted for is what the contractors are delivering to us.
Well, thank you so much for that explanation, Jason. So, you're USGS, and you recently participated in a study that you will be presenting at this week at GeoWeek. Would you like to give us a little synopsis of your findings and what you studied?
Yeah, sure. So I mentioned the NEA, the National Enhanced Elevation Assessment study that we did back in 2012-ish. So as we were coming up to the next generation, we partnered with NOAA to do something called the 3D Nation study. So it's basically a follow-on to NEA, but NOAA also wanted to find out the value and requirements of coastal bathymetric data and elevation data around there. So the study is a lot more comprehensive than the one we did in 2012 was. One of the things that we found is when we took the recommendations and the requirements that people said they needed LiDAR for in 2012. We built a study to collect data that's at least 2 points per square meter with that 10 centimeter RMSE that I mentioned, with a repeat cycle ideally of around 8 years. And so one of the things that the new 3D Nation study has shown us is that the appetite for resolution, accuracy, and temporal frequency have all gone higher. So people want higher res data, they want more accurate data, survey level data that folks that your groups are probably more interested in than general area mapping stuff. And they want it at a repeat cycle of almost every 4 to 5 years. So we can really see how this appetite for this three-dimensional data has really increased over the past 8-10 years now.
Well, I'm excited to learn more, and I'm so glad that you shared this study with me as well. Would love to, and as we wrap up, hear what you're excited about, you personally excited about learning here at GeoWeek 2023, and what technologies you feel you could bring back home to USGS.
Yeah, so being on the advisory board for GeoWeek, it's always great to see how they've grown this every iteration. One of the nice things is most of the conferences that I go to are more focused on the natural resource geospatial side. As the past president of ASPRS, who's also a partner here, it's a really great combination, so we can get those academic papers through ASPRS. We can get the trade show experience through the ILMF component, and then adding on all the BIM stuff that I would never probably go to a BIM conference, but now I'm exposed to that whole different industry is really nice to have in one place and be able to see.
Yeah, and I'm excited to hear what you learned from that as well. Jason, thank you so much for your time. I really appreciate you, and good luck this week.
Thanks.
Yes, sir.